Hello friends, in today's question, three particles A, B and C of equal mass move with equal speed v along the medians of an equilateral triangle as shown in figure. They collide at centroid G of a triangle. After collision, A comes to rest, B retraces its path with the speed v. What is the velocity of C? So we have these three particles A, B and C, and they are moving toward the centroid G of the triangle with the same speed v, and each of the particles is having the same mass. So in this case, we are going to use the conservation of momentum before the collision and after the collision. So let us first of all consider before collision scenario. So before collision, this is our x-axis and this is our y-axis, and we have these particles 3 moving along. This is our particle A, B and C, and each having a momentum, will be having a momentum of mv. So we consider that mass of A, B and C is equal to m. Therefore, momentum of A, B and C will be equal to mv. So this angle will be over 30 degree and this also 30. So we have A particle moving in this direction with the momentum of mv, B in this direction toward the centroid, that is G, and with the momentum of mv, and here also C moving with the momentum of mv. Now let us divide all these, especially from particle B and C, the horizontal as well as vertical component. So one of the component for B will be mv cos of 30, because this angle will be 30, and another will be here as mv sine of 30. And similarly for C, we are going to have this as mv cos of 30, and here also it will be mv cos of 30. So let us write the equation for respective particles along their x and y component. So we can say for particle A, its x component we can write it as pxa, which will be equal to 0 because it is moving vertically, and we can say its y component, it is called as pya, which is equal to mv, and moving in this will be minus v because it's moving downward, so y is positive upward. Next we can write for particle B. For particle B, we get x component pxb, we are going to have it is mv cos of 30, and its y component will be pyb, and that will be equal to mv sin 30. and lastly is for particle C. We can write for its x component is pxc, and that will equal to minus of mv cos 30 rather, minus mv cos of 30. And we have y component pyc, and that will be equal to mv, sorry, that's my mistake, this should be sine not cos, so mv sine 30. Now we can say that total x component for all the particles, total x component for A, B and C, let us call that as px, so which will go pxa plus pxb plus pxc. So we can say our pxa is 0, pxb is mv cos of 30, and pxc is minus mv cos of 30. And please bear in mind, we are only talking about the momentums. Okay, P is nothing but momentum. And similarly, we can write total y component for A, B and C. We can write that P of y is equal to Pya plus Pyb plus Pyc. We substitute the values, so we get Pya is minus mv, Pyb is plus mv sine of 30, and Pyc is also mv sine 30. So this was the momentum before the collision. Okay, so we can also say this is our initial momentum in x direction. Initial momentum along x direction, yeah, x component, and this is our initial momentum in y component. Equation number 1, and we have this as equation number 2. Now let us do it for after collision. After collision, so once again, this is our x-axis and y-axis. 3 particles A, B and C, and it is said that A comes to rest, so this is 0, and B retraces its path, moves back, so in this direction it will be going to have mv, and C we are supposed to find out, so let us call that as V. So we are going to write for B, it will be now, this is 30, so this will be our mv cos of 30, and this will be our mv sine of 30. So for particle A, we have you can say p prime xa, that is x component, will be 0, as well as p prime ya is equal to 0, and here p prime is momentum after collision. Now for particle B, we have its x component, p prime xb is equal to minus mv cos of 30, and we have its y component. It will be coming as p prime yp is equal to mv sine of 30. Now we can do it for, you can say, particle C. So for particle C, we have the x component, and p prime xc is, let us suppose, is mvxc, okay, velocity in x direction, and y component is p prime yc is equal to mvyc. Okay, so this is velocity in x direction and velocity in y direction. Similarly, we can find out the total x component. So you can say total x component for A, B and C. This will be p prime x is equal to p prime xa plus p prime xb plus p prime xc. We substitute the value. P prime xa is 0 and xb is our minus mv cos of 30, and we have for xc it is mvxc. This is x component, and similarly we can write it for y component also. So we can say total y component for A, B and C. Let us call this as p prime y, which will be equal to 0, p prime ya plus p prime yp plus p prime yc. So ya is 0, p prime yp will be our mv sine of 30. Yeah, mv sine of 30. And for C it is mvyc. Now let us, this is our final x component. Let us call this as equation 3, and this is our final y component. Let us call this equation number 4. Now equating the final initial x component as well as y component. So by conservation of momentum, we can say by conservation of momentum, we have px is equal to px prime. We substitute the values. Px was over 0 plus mv cos 30 minus mv cos 30 is equal to, and px was 0 minus mv cos 30, 0 minus mv cos 30 and plus m vxc. Now m cancels out throughout, and we have our this v cos 30 is minus this, and this also cancels out, and therefore we can say that our vxc is equal to v cos of 30, or we can say vxc is equal to v upon cos of 30 is square root of 3 divided by 2. So this is the x component of velocity of c. So you can say vxc is equal to v square root of 3 by 2. This is x component of velocity for particle c. Let us call this as equation number 5. Now again, once by the conservation of momentum, we can say py is equal to py prime. Y component is equal to y component. So we substitute the values. So we get this as minus mv plus mv sine of 30 plus mv sine of 30 is equal to 0 minus mv sine of 30 plus mvyc. Once again, m cancels out throughout, so we can say from here our v by c is equal to minus v plus v sine of 30 plus v sine of 30 and plus v sine of 30. Taking v as common, so we get v by c is equal to, take v as common, and in between we are going to get as minus 1 plus sine of 30 plus sine of 30 plus sine of 30, that is 1 by 2 plus 1 by 2 plus 1 by 2. So this will be 1 by 2 plus 1 by 2 plus 1 by 2. So this is equal to v minus 1 plus 3 by 2, or we can say this will be coming as v by 2. So we get v by c is equal to v by 2. That is the equation number 6, and this is the y component of the velocity for particle c. This is y component of velocity for particle c. Therefore, we can say velocity of particle c will be equal to its x component, y component and square root. So we come as v square root of 3 by 2 whole square plus v by 2 whole square and square root, we get Vc is equal to, taking v as common, this will be 3 by 4 plus 1 by 4, and you can say this will be v is equal to 4 by 4, or we can say our velocity of particle c is equal to v, meter per second. So this is the net velocity of particle c. Now in some of the cases, some of the solutions can be also done in the form of the coordinate, that is taking I, j and k, I and j only, and some of the cases it can be also done in the form of the directly using the conservation momentum and respectively finding out the resultant, and that will be equal to the third component in this case in order to conserve the momentum. But ultimately in all the cases we are going to prove or come to the conclusion that the velocity of particle c is nothing but v meter per second. So this completes the question. Thank you.